Well, today our neighbour's sheep escaped and I was helping them with those, and then I was given this to fix. So it's one of the board things, and in the connector one of the pins is snapped off, so I'm going to put another connector on there, and I'll do the same on the charger. But I'm not sure about this charger at all. It's just so light and cheap and nasty feeling. I certainly hope it doesn't go on fire anyway. Yeah, and I've got all these batteries to sort out. Just got aluminium tabs to solder on these, and these are all good cells that are recovered from the bad bike battery. I've got enough there to make a 12 cell 10 amp hour battery. But moving on to this. So the connector I'm going to use is what's known as an MT60 connector, and it's used for as a quick release connection, usually for speed controllers on remote control models. But because the charging connector has 3 contacts, this has 3 contacts, I'm just going to epoxy or glue this in. I'll probably put the male end in there, and it'll just be sort of sticking out like that, and that'll give a brilliant connection. And if they manage to break that, they're doing something wrong. In fact, there's only actually 2 wires in use, and one of the pins is not actually used, but the pin that's broken off is used. So this pin right here, that's the unused pin, so all that was left connected is a positive, so I could just use an XT60 connector on there. So we'll have a look inside. This is it uses all the same sort of connections as you'd encounter on an electric bicycle. That's probably the board with accelerometers that does all the control and stuff like that, balancing. And that's the inverter board which drives the motors. 2, 3, 4, 5, 6. Just a small 6 FET controller. I'll need 2 banks of 6, one for each motor. Yeah, the last part is going to be a bit of a struggle getting this through. So here's my solution. I've just got an XT60 connector in there. The male one, I think this is, goes in here, or I think it's the female side actually, and then I'll solder the other one in there, and that fits really well. I just filed out the shape. That's a nice tight fit. I'll just use hot melt glue to secure it. So here's the stage I was at, and basically what I did was inserted the connector after filing sort of a shape for it to fit around. Well, I filed a hole that was sort of XT60 shaped, and then applied hot melt glue, and then after that also put the soldering iron on the hot melt glue, and that makes it go really roasting hot and runny, and it makes it stick much better. So this should hopefully be secure enough, and I'll just to make the connection now, I'll just solder that. So here's the battery in here, and it's already got an XT60 connection on it, and it'll have the built-in battery massacre system as well. So I hate those things. If I'd ever bought one of these for myself, I would take the BMS right out, and I'd use an external charger and balancing system so I can monitor the cell voltages. Because it's down at about 3 volts per cell just now. I measured it earlier, and it's pretty much completely discharged. So there is a management system in there. I'm not going to take all of this apart, but chances are the cells are all out of balance, and when I charge it up again, some will probably go over 4.2 volts. And it's a shame really that they make these things charge all the way up to 4.2, because it just really shortens the life of lithium batteries. If they set them to 4.1, then it would help an awful lot. There's just no point charging to 4.2. So the battery is at 30.33 volts, so it is very low. I'm very sure it's a 10 cell battery, so I think because it's charged to 42 volts, and that's what you charge a 10 cell battery to if you want to seriously reduce its capacity over time. But because I think what 1, 2, 3, 4, I can only count 4. It would usually maybe got 5. Well, I thought we'd have had 5 sort of 18650 size batteries. I'm not entirely sure how it's structured inside. There might be more cells on the top section here. So I'll put it all back together and put it on charge, and I'll put a watt meter in line with the charger to see what's going on there. So now we're ready to do a test, and as you can see, this piece of crap charger is producing 42.27 volts, which is too much. But we'll plug it in anyway. The voltage will drop right down. And nothing is happening at all. Oh, that's not too good, is it? No current flow. Maybe it has to be switched on to charge. Yeah, it's just not charging at all. Okay, so there's a fault with the feature which prevents you from actually using the device while it's charging. I think it's something to do with that MOSFET allowing the connecting the charger. Something's just not working there. So basically, I've just connected the charger input right directly to the battery, and the battery's got its own management inside it. Crap as it is, but it's got it. Wouldn't surprise me if in a few months' time this thing bursts into flames, so I'll warn them about that. But I won't burst into flames because of this modification. It's just because of its poor design. I've heard about these going on fire, and I could quite easily believe that. So, time to put it back together and charge. Got the Chinese overcharger connected. Let's plug it in. See how many watts this is. So we've got 1.21 amps, so it's 43 watts. And this piece of crap says it actually charges at 2 amps, but it doesn't. And it's so light, and sometimes you can hear the circuit or whatever rattling around inside, so I don't think it's very safe, to be honest. And I will warn the people about it when I give it back. So I'll let that charge up, and then we'll give it a try, provided it doesn't go on fire. Okay, so now I'm just charging it directly off the off-grid LifePo 4 bank down there, and I'm just using this step-up converter, and I've set it to just about 41 volts. And I could set this to charge at 5 amps if I want, but it's only a 4 amp hour battery in there, so I'm just charging it at just half that. So 41.2, which is a bit more of a reasonable voltage. 41 would be an ideal design voltage for this, because that means 4.1 volt per cell, assuming it's a 10 cell battery that's in there. But yeah, I think that's it fixed. I'll just have to let it try, then I'll give it and I'll just sort of ride it around outside. I've never used one of these before, so I'll probably fall off it. So that should be good fun if it survives. So the repair's been successful. The original charger takes up to 42.2 volts. and it's just too much, unfortunately. So I don't think this thing's going to last very much longer when I give it back to its original owners. So I'm just going to turn it on and give it a test just now. But yeah, this is what it looks like. That's just directly connected up to the battery, so they'll have to be careful about that, try not to crash it and damage that connector, or stick anything metal in it, because this actually belongs to quite a young kid, I think. Yeah, so I find it a bit difficult to use the first time, but it's usually just by tilting your feet, or you can lean forward. It really doesn't matter. But yeah, it's just getting off it's a bit hard.